Wait a sec. Good morning. See if we can pick up a couple people getting out of bed.
Hey, Mr. McKay,
Hi.
how did you do, or like, where do we start for number 16 on the assignment?
Let's see what number 16 is. This one, 8 and 9.
8 and 9? What do
Is,
you mean?
is it, this is this one? Oh, shoot. Let's see. What's going on? Oh, poo. I was, it's the assignments for RF 7, 8, and 9.
Oh, yes.
Oh, okay. You said 16? The one.
Yeah.
Uh, State the transformation. So you're just saying. mm, Um. ah, So what are the transformations? Is there a vertical stretch? Like you're talking about this horizontal stretch, horizontal translation, vertical translation. That's all it's asking. Like HT equals VT equals that one. I think that's the only question 16.
Yeah. But, like, how did you, do you, like, change it to log? Or, like, how do you do that?
No. Is there a number out in front? Is there a vertical translation, a horizontal translation, or those two are stretches, and then the two translations? So you don't have to convert it. You're just like, this is graphing exponential stuff. This 15, 16, and 18 are from RF7 when we did graphing exponential functions, like those ones, exponential growth or exponential decay. Does that help? It's not
Yeah,
supposed to be. It's not supposed to be a complicated question. Hello.
okay. And is that kind of like the same with 16? It's just, like, back in 7?
Yeah.
Okay,
Okay.
thanks.
No problem. All right. On Friday, we looked at solving exponential equations. If it has a common base, we can cancel them out. Effectively, we're taking the log of both sides. Um, if it's not common, you have to put it into a common base. We can isolate by adding, subtracting, and we did those. If it doesn't have a common base, we need to get the exponential on its own, and then take the log, whether it's base 10 uh, or base e, doesn't really matter, of both sides, and we get that kind of ratio at the end. And we did those. I went and found, if, and I'll update this at the end, solved by putting in a common base, solved by logarithms. Those are the ones that kind of we did today. We'll look at some other stuff. So today, I just want to go over logarithmic, or the first part of logarithmic equations. Um, if there's one logarithm, is one set of stuff. If there's two logarithms, it can be a little bit more complicated. So we're going to do this, and there's some questions kind of at the bottom, which I just want to do this first because I added to it. Sorry, full page, all. Oh, wrong. Uh, is this mine or Mrs. Legier's? Okay, we're gonna. It's not even the. Put it in the right spot. Yeah, sure. This will be nice and quick. Um, so evaluate if you can. If you can take a logarithm. The other trick, if there's only one thing, put it into an exponential form and see what you can do from there. So we have something as simple as questions that we've done for a little bit. Log base 6 of 36. What power do you raise 6 to get 36? Well, that's just 2. If it's a base 10 conversion, we're going to do, oh, how do we, oh, technically 2 to the x equals 135. Log of 2 to the x equals log of 135. X times log of 2 equals log of 135. And then we can throw that into our handy dandy calculator. 7.08. That's kind of stuff we've done before. If the variable is the base, which takes us to, if you can't evaluate it, and this is in your head or base 10 conversion, rewrite it as an exponential. Those are the two strategies. So our base is x. Our exponent is 3 equals 125. Some people are going to be able to look at that and say, I know what x is, but this is x cubed. So take the cube root. The cube root of 125 is 5. Same idea, convert it to exponential form. X to the 2/3 equals 16. So this, to get rid of that, I don't like dealing with roots for this. Well, the reciprocal of 3 over 2, if I multiply that out, we get x to the 1. So we raise this to 3 over 2. So x equals, now I can put it into the square root of 16 cubed. Uh, I can do the square root of 16 in my head. The square root of 16 is 4 cubed. That's a little bit easier. So 4 cubed is 64. So if that was log of x equals 3 over 2, you do the same thing. I would square it and then do a root. It just depends on what the calculation is. Unknown variable is the argument. These, again, we've been doing a whole bunch. Convert it to 3 to the power of 4 equals x. Well, now I can use my calculator. 3 threes are 9, 9 threes are 27, 27 threes are 81. Excuse me, you can use a calculator if you need. 2 to the power of negative 5 equals x. I'm just going to write it. X equals 2 to the negative 5. So that is 1 over 2 to the power of positive 5 using our exponent rules. 2, 4, 8, 16, 32. 1 over 32. Ooh, ln of x equals 7. E to the power of 7 equals x. Well, this is one I can. If you take calculus and it hasn't changed a lot from when I was in university, which was a long time ago, and you see the words exact answer in a question, the exact answer to that question is e to the power of 7, because e is an irrational number. Any approximation is just that, an approximation, 1096.633, da, 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 da. So that's usually fairly standard. Like there's nothing, oh my gosh, too crazy about that. Now when we get to, oh, we've got some variables. We've got some variables. Oh, that one looks crazy messy, but we'll get to it. Log base 5 of x minus 10 equals 2. Convert it. 5 squared equals, whoops, not x to the minus 10, that's stupid. X minus 10. Well, can I make 5 squared a number? 25 equals x minus 10. Add 10 to both sides, 35. Checking our answer, 35 minus 10 is 25. 5 to what power is 25? That would be 2. Another one where we have to convert the base is 10 to the minus 3 equals x. I'll just write it like that. Equals 1 over 10 cubed equals 1 over 1,000. Ooh, hot dog. Look at this fun thing. So, let's see what sort of fun. Oh, 2, write it in to the fifth equals e to the 2x plus 1. My gosh, it looks complicated. It looks a little bit bizarre. Is 2 to the fifth a number? 2, 4, 8, 16, 32 to the 2x plus 1. Now it's an exponential equation. How do we get rid of that? We take the log, or I'm going to use, because it's the base e, ln of both sides. Ln of 32 equals ln of e to something is, those go away, 2x plus 1. Now this is another one where you could convert that to a decimal, but let's do it the pre-calculus, the proper way. Ln of 32 minus 1 equals 2x. Divide by 2, divide by 2. X equals the natural logarithm of 32 minus 1 divided by 2. Now we have, I didn't teach a lot of you pre-calculus. I don't know what Mrs. Paralee's stance was. When you do the quadratic equation in pre-calculus and it says state an exact answer, x equals plus or minus the square root of 2 minus 3 over 4. That's an exact answer. If this question says state an exact answer, that is the exact answer. A decimal is not an exact answer, and this is something most high school students hate. And it baffles them and bothers them and all of that because everyone loves decimals, because science enjoys decimals. But in math, that's an exact answer. I can approximate that, and I usually don't, but technically that needs an approximate sign. 32, oh no, n is that, minus 1 is that, divided by 2, it's approximately 1.233. It's not exactly that because we've used a decimal. So that's solving some logs. I'm going to skip down here for a second. Solve using common basis, solve using logs, solve for x. We can do different things, and some of those, I think we could probably do all of them. 2 logarithms, 1 on each side, or 2 on the same side. We're going to look at Those, the first couple of these, because it's only quarter after. Um, this says eliminate. Log 3 of 2x, log base 3 of 2x equals log base 3 of 16. You could try all sorts of fun stuff. We say eliminate. Really what we're doing is raising it to the power. We're taking the anti-log, or 3 to the power of log base 3 of 2x equals 3 to the power of log base 3 of 16. 3 to the power of log base 3 goes away. So we're left with 2x. 3 to the power of log base 3 goes away, equals 16. X equals 8. When we say eliminate, really, if I kind of looked at that again, log base 3 of 2x equals log base 3 of 16. That and that are going to be opposite. So 2x equals 16, x equals 8. So we can do that sort of thing. Um, However, we have to use our log rules. If I've got a number in front, we have to move that up. Log base 5 of 4x equals log base 5 of 2 cubed. Well, that's log base 5 of 4x equals log base 5 of 8. Whether you eliminate it, just to me, for 5 to the power of log base 5 of 4x equals 5 to the power of log base 5 of 8. Cancels because they're inverse operations. 4x equals 8, x equals 2. Uh, Look at this one and call it a day, because that has 2 logs on one side. Ln of 2x plus 5 equals ln of 15. E to the ln of 2x plus 5 equals e to the ln of 15. Those go away. 2x plus 5 equals 15. That's got different bases, so that's a little bit of an issue. 2x equals minus 5 equals 10, and x equals 5. So those are the kind of log equations, the simple ones. Can you just say go away, 2x plus 5 equals 15? Technically, yes. It's not my favorite thing in the world, but some of it is how I was taught, and I would have lost marks if I didn't say I was doing the inverse operation. Um, Tomorrow we'll look at the rest of those, which are a little bit trickier because they have different things. At the bottom of this page now, this is what we did on Friday. Convert that to a 3, move everything over, convert whatever you're left with to base 4. These ones I would well, you could use 8, I guess. This you have to take the log of both sides, or the natural log if you're talking about that one. You could use base 10, it doesn't really matter. Solve for x, those are going to cancel. Move that over and get rid of. And that's some of the stuff that we did today. And we'll leave 15 till that. So that's all I wanted to do today. If anyone, whoa, we've lost some people. Apparently that wasn't exciting enough on a Monday morning. I thought we had 6 or 7. Anyway, so that's everything. Oh, good, I've recorded. We'll continue with the rest of those tomorrow if you want to try some questions to practice, but that's all I have for today. So you're welcome.
Thank you, Mr. McKay.
You're welcome. Have a good day.
You too.
Thanks.